Hi everyone, in this video we will go through the concept of limiting reactants. You can start by exploring the simulation over here, but I will just go straight into some examples and the concept of what limiting reactants are. At the end of this video, you should be able to recognize questions that require the use of limiting reactants and apply the concept in performing calculations. Let's begin by looking at a very simple example. Imagine you are making cheese sandwiches, okay, and you need 2 pieces of toast with 1 slice of cheese to make a sandwich. So when we talk about a balanced chemical equation, right, we will say the mole ratio is 2:1:1 because 2 slices of bread plus 1 slice of cheese gives you 1 sandwich. So in terms of ratio, 2:1:1. When we make 1 sandwich, when we use up everything, essentially there is nothing that is left over. So nothing is in excess if we use the exact quantity. Let's work with another set of numbers. Let's say I'm going to use 10 slices of bread with 12 slices of cheese. Okay, then the question here is, what is the maximum number of sandwiches that I can make using this quantity of reactants? So you'll probably answer that it is 5, correct? I have not enough bread, right? So I'll use up all my bread to make just 5 sandwiches. And in making that 5 sandwiches, how many slices of cheese do you use? You use 5 pieces also, right? Which means there are 7 pieces in excess. In other words, we say that the bread here is limiting. Okay, limiting means that it's totally used up in the reaction. Okay, not enough. Alright, we work with another example. This time round, I have 14 slices of bread with 12 slices of cheese again. What is the maximum number of sandwiches I can make? You'll probably be able to guess again. This will be 7. Correct? So this time round, what do I not have enough of? Again, bread is not enough, and we say bread is limiting. In making that 7 sandwiches, I used up 7 slices of cheese. I'm left with 5 pieces of cheese in excess. Correct? So let's tidy this up a little. From this example, I want you to be able to make a few observations. So number 1, you realize that the limiting reactant is completely used up in the reaction. In this case, I have no bread left over after making the sandwiches. Okay. The second thing I want you to take note of is that the limiting reactant will determine the amount of product that is formed. Okay, so in determining how many pieces of sandwiches I can make, I have to look at the limiting reactant, the one that is not enough. Okay, and the third thing I want you to take note of is that the limiting reactant is not necessarily the one that has a smaller quantity. What do I mean? If you compare the 2 examples here, okay, let's name this example 1, example 2, example 3. If we look at example number 2, I have 10 and 12. 10 is the smaller number. Okay. In example 3, I have 14 and I have 12, yet 14 is still the limiting reactant. Even though I have more slices of bread than cheese, that is still the limiting reactant. Why? Because in making a sandwich, I need twice the number of pieces of bread for every slice of cheese. That is what I mean when I say not necessarily the one that is in smaller quantity. You have to look at the ratio that you need in the reaction. Okay, so I've summarized what I've said at the bottom here, and in yellow I highlighted very importantly, when you do calculations, always determine what is the limiting reactant. Okay, let's work through a few examples and you'll have a better idea. Okay, so one look, how will I know that this question requires me to apply the concept of limiting reactant? So you have to read. This question gave me the quantity of 2 reactants. So when you are given the amount of both reactants, you cannot assume which is in excess. You have to determine the number of moles if it's not given, and then compare the ratio. So how you identify is that, okay, in this case, I'm given 5 mole of nitrogen and 10 mole of hydrogen, right? We compare the ratio just like our sandwich example. 5 mole of nitrogen requires 15 mole of hydrogen because 1:3. So 5:15. But I'm given only 10. So not enough of hydrogen hydrogen is the limiting reactant. Okay. In part B, when they ask you to determine the amount of product formed, you have to base it on the limiting reactant. Okay, so I can ignore the nitrogen over here. From the 10 mole of hydrogen, how much ammonia can I get? Look at the mole ratio. Okay, so since hydrogen is the limiting reactant, your number of moles of ammonia that can be formed will be 10 divided by 3 times 2. Okay, because the mole ratio is 3:2. That will give us 6.666. Alright, and then we round it off to 3SF, 6.67 mole. Look at example 2 now. You may want to pause the video and try it out before we carry on. So the correct answer here is A. Let's see why. We have 20 cm cube of propane and 140 cm cube of oxygen. Again, how do I know this is a limiting reactant question? I'm given the quantities of 2 starting materials. Okay, I need to compare the ratio now. Since they are all gases, remember we say that mole ratio is the volume ratio. So I don't need to convert to moles. I can directly compare the volume here. 20 cm cube would require 1:5. So therefore 100. Since I have 140, oxygen is in excess. I need 100, but I'm given 140. So the other one must be the limiting reactant. So the volume of carbon dioxide produced, you have to base it on the limiting reactant, which is a 1:3 ratio. Therefore, 20:60. Alright, question number 3. Again, pause the video and try before I go through the answer with you. First, I noticed that I'm given the quantity of 2 reactants. I need to find the limiting reagent. Start by finding number of moles. For HCl, number of moles is concentration times volume, 0.05 mole. Number of moles of calcium carbonate, 2 divided by the MR, CaCO3. How to write statement for limiting reactant? Okay, we can say 0.05 mole of HCl requires, so I'm looking at HCl, compare 2:1, so 0.025 mole of calcium carbonate for complete reaction. Since only 0.02 mole of calcium carbonate is available, CaCO3 is limiting. Calculate the volume of carbon dioxide formed. We base it on the limiting reactant. In this case, it's a 1:1 ratio. So my number of moles of carbon dioxide is the same as this. So the volume, mole times 24 dm cube. In this case, we have 0.48 dm cube, or you can say 480 cm cube. Okay, you may want to try part B. Again, it's quite similar, just that I vary the mass of calcium carbonate here. Okay, I'm going to do the same thing again. Find number of moles. Right, so the number of moles of HCl, 0.05 mole. Calcium carbonate, 0.03 mole. Just now, when we compare the limiting reactant, right, we use HCl compare with CaCO3. Can we do it the other way around? Actually, it doesn't make a difference. For the second example, I will do it the other way around so that you can see how it's done. So it doesn't matter you look at HCl requires how much of CaCO3 or the other way around, you will get to the same answer. So if we have 0.03 mole of calcium carbonate, how much will it require? 0.06 mole of HCl. Since only 0.05 mole of HCl is available, HCl is limiting. This time we are using HCl to compare to carbon dioxide, which is a 2:1 ratio. Number of moles of carbon dioxide will be half of it. So the rest is the same, multiplied by the 24 dm cube. Okay, so if you look at the two examples, they are the same except for the quantity of calcium carbonate. You realize that in the first example, calcium carbonate was limiting. In the second example, HCl is the limiting reactant. Okay, reiterate again, doesn't mean the one that is in the smaller quantity is the limiting reactant. As you can see, you must look at the ratio in which they react. More practice questions in your notes. Let's try. Again, this is a limiting reactant question because there are two quantities given. Start by finding number of moles of each of them. So we put up the statement again to find what is the limiting reactant. 8.571 because it's a 1:3. Okay. So for those of you who did it the other way around, I will just write the alternative, or you can do it as. So now we determine that calcium oxide is the limiting reactant. When we want to find the maximum mass of calcium carbide, we use calcium oxide. So mole ratio is 1:1. I will not write it down. It's the same, 2.857. Okay, three significant figures, 182 grams. Okay, last example. Write the equation first. We are burning hydrogen and oxygen. I have 50 cm³ of hydrogen and 125 cm³ of oxygen. This time around, I won't go into writing the statements. In case this is an MCQ question, right, you can follow how I actually annotate. Alright, so we are going to draw a table here. This is the initial volume. That means 50 only requires 25 for reaction because 2:1. But I have 125, so way in excess for oxygen gas. So automatically this is the limiting reactant. Okay, in other words, the limiting reactant will be fully used up. So I'll deduct everything. For every 50 that is used, half the volume is used here because it's 2:1 ratio. Okay, so the change here is minus 50 minus 25. Then at the end of the reaction, I will have nothing left of my limiting reagent, and I'll left with 100 cm³ of oxygen. So you can do a table like this if it's an MCQ question which does not require you to present your answers in statements, so that you can tabulate and see, oh, I have 100 cm³ of oxygen left after the reaction. Okay, so identify the gases present in the mixture after the reaction and the respective volumes. 100 cm³ of oxygen gas is left. Alright, so that's all for this video. I'll see you in class.